What if I told you that the secret behind all this incredible artificial intelligence, the stuff that powers self-driving cars and your phone, isn't some kind of crazy, impossible to understand magic? What if I told you it's actually built on math you learned back in elementary school? It's the billion-dollar question, isn't it? We see these machines doing amazing things, and it feels so complex, so alien. How does a computer go from knowing absolutely nothing to being an expert? You're probably thinking it's all super advanced calculus, but the truth is, the journey starts somewhere way, way simpler. Yep, that's it. The real engine driving machine learning is just the basic arithmetic we use every single day. We're talking addition, subtraction, multiplication, division. These aren't just for splitting a restaurant bill, they are the absolute fundamental building blocks of intelligence. So, let's open up this toolkit, shall we? We're about to look at the exact symbols that, when you put them together in the right way, let a machine sift through data, spot patterns, and, well, actually learn something. And here they are, the stars of our show. You've got the classics, plus, minus, times, and divide. But we also have a few specialists. There's floor division and modulus, which are fantastic for splitting things up, and exponentiation for, powers. That's it. This is the whole crew we need.
Okay, so we've got our tools. Now for the really cool part. We're going to see how each of these simple symbols gets a really important job inside a machine learning model. This is where basic math starts to look a whole lot like intelligence. Addition, at its heart, is about bringing things together. So in AI, a model makes a ton of tiny mistakes, right? We call those losses. Addition's job is just to add up all those little mistakes to get one big score of how wrong the model currently is. It also helps give a little nudge to a neuron's final decision by adding something called a bias. Now this is the heart of it all. Seriously. An AI makes a guess. We know the real answer. Subtraction's job is to find the difference between the two. That difference is the error. Without this one simple calculation, the machine would have no clue it messed up. It could never, ever get better. Think of multiplication as the model's volume knob. It lets the AI turn the importance of some data way up and other data way down. It's also how we control the size of the steps the model takes when it's learning. That's the learning rate. Multiplication makes sure it's not learning too fast or too slow. Division is all about fairness and getting some perspective. If you're comparing someone's height in feet to their income in thousands of dollars, the numbers are on completely different planets. Division helps us normalize everything, putting all the data on a level playing field so we can make fair comparisons. It's also key for figuring out probabilities, like the odds an email is spam. Okay, the modulus operator, the one that finds the remainder, might seem a little weird, but it's an absolute genius at logistics. Imagine you have a data set with 10 million photos. You can't just shove that all into the computer at once. Modulus is like a car dealer, perfectly and efficiently dealing that massive deck of data into small, neat piles or batches that the model can actually work with. All right, enough theory. We've met the individual players. Now let's see how they team up and get things done in some real-world machine learning scenarios. So, remember that normalization thing we just talked about? Here it is in action. First, you take your number and use subtraction to see how far it is from the average. Then, you use division to scale that difference. And boom, just like that, subtraction and division work together to perform a super important step in preparing data. This right here is the learning loop for so many AI models. It's a little dance. Step 1, multiply to figure out how big of a correction we need to make. Step 2, subtract to actually apply that correction. This tiny process, multiply, then subtract, repeated millions and millions of times, is literally how a machine gets smarter. And here's our data-dealing dream team. Say you have 105 data points. Floor division instantly tells you, okay, that's 3 full batches of 32. Then modulus chimes in, and you'll have 9 left over. It's just an incredibly fast and elegant way to slice up your data so the model can digest it. So you can see the foundation is surprisingly simple, but to go from just understanding this stuff to actually building powerful AI, there are a couple of pro tips you really need to know for making this all work at a massive scale. When you're dealing with big data, speed is everything. Doing math one number at a time in a loop is fine for a small list, but for millions of data points, it's way too slow. That's where vectorization comes in. Libraries like NumPy let you apply one operation to an entire list of numbers all at once. It's the difference between doing math with a calculator versus a supercomputer. It's absolutely essential.
And one last thing, a quick but super important detail. You have got to know your division. Standard division gives you the exact decimal answer, a float. Floor division just chops off the decimal and gives you a whole number, an integer. If you're trying to find an item's position in a list, you need a whole number, and using the wrong division operator will break your code. It's a small detail that makes a huge difference. So, there you have it. The whole intimidating world of artificial intelligence really does stand on the shoulders of the same basic math you've known for years. It's not some locked fortress of impossible complexity. It's just a toolkit, a really powerful toolkit that's waiting for you to use it. So now that you know the secret, the only real question is, what are you going to build?